Welcome everyone. My PhD thesis is Imbalance in vascular reactivity between healthy women and men. I am Ádám. I am a dentist, an endodontist, and a PhD student. I work from the Department of Restorative Dentistry and Endodontics, and my supervisors are János Vág and Beata Keremi. My SMS is Petrana, and I work with the statisticians Alice Fazekas and Gergely Jogócs. My vision is improving the quality of female patients with cardiovascular and periodontal diseases through providing evidence-based data for personalized care. Here's the list of my two specific goals which I started last year. And the first one is comparing vascular reactivity between healthy women and men on macro and microvascular level, a systematic review and meta-analysis. Cardiovascular diseases are the leading cause of deaths globally for both men and women. Endothelial cells have an essential role in maintaining the cardiovascular health, for example, for modulating vascular tone and hemostasis. The age-adjusted CVD death rates and incidences are higher in men, and one possible explanation behind this is that the protective function of estrogen, as the endothelial cells are targets for estradiol, and the estrogen modulates the endothelial function. Despite all of these differences, women have been underrepresented or even excluded from clinical trials. When we want to assess endothelial function, reactive hyperemia comes in handy, which is a complex phenomenon evoked by transient ischemia, and it can be utilized even on macro and microvascular levels in a non-invasive way. The influence of sex on reactive hyperemia measurement remains uncertain. So our aim is to compare reactive hyperemia between healthy females and males. Our question, is there a difference in reactive hyperemia between healthy females and males based around the PFO framework, where P1 and 2 is reactive hyperemia in the brachial artery and on the skin, F1 and 2 are healthy female and male patients, and the outcomes are change in artery diameter and change in blood flow. Our hypothesis is that women have higher reactive hyperemia than men. The systematic search was carried out in 3 big databases, and you can see the attached search key on the slide. After the selection process, we are left with 93 eligible articles. The skin blood flow change analysis is still ongoing. However, we are ready with the brachial artery results, although it needs some minor adjustments. The first outcome is the relative artery diameter change. As the titles suggest, the outcome measure is the relative artery diameter change. For the female patients, out of the 44 included articles, almost 900 patients were included for the analysis, and the mean dilation for women were 0.1 or 10%. The same analysis with the same articles were carried out in the male population as well. Out of the 44 studies, there were 1.1 thousand male patients included, and their mean dilation was 0.08, which means 8% mean dilation for the male participants. Once again, these are the two genders placed next to each other, and the overall mean for the whole population was 0.09 or 9% dilation. Keep in mind that the female and male confidence intervals slightly overlapping. It cannot be seen with the numbers because it's rounded up. But if we look into the model analysis, we can see that male gender, BMI, and age both have a significant effect on the extent of dilation. The next outcome measure was the relative blood flow change, which is the blood flow change in percent from baseline to peak blood flow. For this analysis, 10 articles were included, and the mean for the female population was 431% reactive hyperemia. The hyperemia for males were 375%, and the overall mean was 405% hyperemia. The same can be stated that the confidence intervals of the two genders are overlapping. However, when we look into the model analysis where the BMI and age are normalized, we can see that the male gender and age have a significant effect on the extent of hyperemia. The last analysis that was carried out is the time to peak artery diameter, which is the time it takes to reach the peak dilation from baseline. For these 8 articles were included for the analysis, and about only 1/3 of the patients were female. It takes roughly about 43 seconds for the female to reach the peak dilation and 54 seconds for the male to reach the peak dilation, and the overall mean was 51 seconds. When we look into the model analysis, we can see that only the male gender has a significant effect on the time to peak. The strengths and limitations of the analysis are the following. There is a huge number of studies and participants included, and these studies were carried out in multiple countries. All of the patients were healthy and non-smoker. However, there are some limitations. First of all, the reactive hyperemia tests are not standardized, and this could have the biggest influence on the considerable amount of the heterogeneity that was present in the studies. Our conclusion is that male has lower hyperemic response. Consequently, it could mean, or it could explain the more frequent CVD event rate in the middle-aged population. And for implications, this could have an impact on personalized medicine, as the two genders have different vasodilatory capacities. And for research, separation of the sexes for clinical trials is strongly suggested, and the sexes should be equally represented in these studies. Here's the progress of the first project so far. And while we are waiting for the remaining plots, the manuscript was started and the introduction and master section is written, and the target journals are the top journals in cardiology. My second project is comparing post-occlusive reactive hyperemia on gingiva and forearm skin between healthy women and men, an observational study. Studies on big arteries and skin suggest that females have higher reactive hyperemia. Post-occlusive reactive hyperemia tests are commonly utilized to evoke changes in macro and microcirculation as well. And for its measurement, laser specular contrast analysis not only can measure it properly, but it even can visualize its readings by rendering the readings to a two-dimensional heat map. An earlier study showed that when the post-occlusive reactive hyperemia test was carried out on the gingiva, the men had a more prolonged and pronounced hyperemia. So the question arises, do females have higher reactive hyperemia on every body part? Our aim is to compare the pore on different regions between the healthy females and males. Our question, is the reactive hyperemia higher in females on the gingiva and the skin as well? Based around the PFO framework, where P1 and 2 is pore test on the gingiva and the forearm skin, F1 and 2 is the healthy female and male population, and the outcome is change in blood flow in laser specular perfusion units. Our hypothesis is that women have higher hyperemia in both regions. And the outcome is that the implication is it could have an impact on the wound healing. For recent clinical trials, I can show you two, where the pore test and vasoactive molecule was applied on the gingiva, and in both studies, the result was that male had a more pronounced and prolonged hyperemia. As for summary, these were the two projects of mine. And for the first project's planned submission date is next July. To know is to know that you know nothing. That is the meaning of true knowledge. Thank you for your attention.
In this presentation, I was fascinated by one of your maybe secondary findings, the effect of body mass index on on wound healing. Could you please elaborate on that and elaborate on the clinical implications about it?
Thank you for the question. And from the model analysis, it can be seen that with higher body mass index, the extent of hyperemia gets lower and lower. That would mean that for patients with bigger indexes, the compensation for ischemia is lower in these patients. And in wound healing, of course, the circulation, so when a wound appears, the circulation of the area gets blocked off. And if the hyperemia is higher in the region that after ischemia, that would mean that more and more factors for wound healing in a shorter period of time appear in the region, and that would accelerate the wound healing.
Can you explain a little bit, based on your results, how can we transform these results to the clinical practice? What is your future project on maybe clinical trial? Are you planning to do some of it based on your results from the first two projects? And if yes, what would it be?
Thank you for your question. If I understand it correctly, what is the connection between the first and the second project? Okay, to be completely fair with all of you, the initial idea for my PhD topic was to start with the clinical trial. However, when we looked into the literature about what is the mean hyperemia for the male patients, what is the mean hyperemia for the female patients, we could not find constant results for that. And this is the reason why we started with the meta-analysis with the first project. And of course, there are no sort of macrocirculation in the gingiva. So we had to start with the big artery, and the brachial artery is very well accessible, and it's commonly used for the post-occlusive reactive hyperemia tests. And also this post-occlusive reactive hyperemia test can be carried out on microcirculation on the skin everywhere on the body. And we wanted to see, so the connection between all of these, we wanted to see if the relevance, it is the same whether the female have a higher hyperemia on the macrocirculation and the microcirculation. And if it's true for the brachial artery or macrocirculation and the skin, is it true for the skin and the gingiva as well? So is there a difference between body parts regarding microcirculation or the regulation of the microcirculation based on the body parts?
My question is about the age of the patients. I mean, BMI, I have a high BMI, so I don't ask questions about BMI, but the age, you see, I mean, as somebody gets older, I mean, the reactive hyperemia could actually decrease. So were these treated or handled in the studies? Because maybe you have something underestimation in the overall outcome because of this, the wide range of heterogeneity of different patients.
Thank you for the question. Well, if we look at the forest plots, the BMI and age is not taken into consideration, but when we look into the model analysis, we can see that both of them have significant effects, and the reactive hyperemia indeed decreases with the age.